Hey, so welcome back, and this is another daily code problem. So today it's called minimum cost for tickets, and it's a medium level dynamic programming problem. So you're just given an array here called days, and so this just represents the days of the year that you want to travel on. So you want to travel on day 1, day 4, 6, and so forth, but you can see here you don't want to travel on days 2 and 3. Now the cost array just represents the days or the cost for a particular ticket, and so the first ticket is for a 1-day pass. The second cost is for a 7-day pass, and then the third cost is for a 13-day pass, or 30-day pass, sorry. And so essentially you're paying $15 for a 30-day pass, but only $2 for a 1-day pass. Okay, and so essentially this is a minimization problem where you want to just pay the least amount possible to travel on these particular days of the year. And so if we kind of looked at the top-down approach, what that's going to look like is, say you start at day 1, and so you're going to have 3 options. You can either go to day 2 with the cost of 2, or you can move to day 7, or day 8, sorry, for a cost of 7, or you can move all the way to day 31 for a cost of 15. And then you kind of repeat these choices once again with every single possible path. And then they kind of continue on, and this just keeps spreading until you reach the base case. But you can see here, you don't want to pay for like a 30-day pass, say if you don't travel between any of the days between 1 and 30, because you only really need a 1-day pass, which only costs $2. So you want to minimize it. All right, and so to do that, and I'll show you how to do the bottom-up approach after this, but it's important for you to understand how to do the top-down approach. So typically you define a DP function here, and let's go ahead and do that. And so it's going to start at saying, okay, we want to be looking at some index, so we're going to have a pointer that points to the current day that we're looking at, as well as like what's the day that we've paid up to. So let's just call it like paid days. Paid days. And typically, because we want to cache this for memorization, let's go ahead and add that annotation. So the first thing is we want to define our base case because this is recursive in nature. And so if I is greater or equal to the length of the days, we've kind of reached the end of the days that we want to travel. So let's just return 0 here, right? So that means the pointer has reached this point. So let's just return 0, which propagates the answer upwards and allows us to kind of add the costs downstream. So let's do that here. So we're expecting to have some minimal cost that we're returning. And so initially this minimum cost, let's just define it as infinity. And so that way we make sure that it is actually being minimized. So let's just start at the biggest number possible. And so to do that, we want to say, okay, let's explore those 3 different options here. So let's go through every cost in our cost array. And just for simplicity, you can actually use something called zip here, which just allows us to also compare it to, okay, this is for a 1-day pass, this is for a 7-day pass, and this is for a 30-day pass. So we can just say day pass here. Okay, and so once again, we want to be updating this minimum cost, which is just basically the minimum of itself, as well as, and this is just a common pattern that you want to do for these DP functions, is that you recursively call this function, and let's move on to the next day. And we want to increment basically the paid days here. So that's just going to be, okay, what day are we currently on? So days at I, and then plus the number of days that our pass allows us to go. Okay, and so essentially all that we're really missing here is, and I'm just going to fill in these parameters, is right now it's just returning 0 and no cost is ever being added. And so you can just do that here. So this is going to be, okay, what's the current cost for the next step? But let's also add what the cost was in order to have this day pass. And that's just going to be the cost here, right? And we just define that over here. All right, and so the only other thing that we have to handle here is, okay, if we've already paid for that day, let's just move forward. And that's just going to be, okay, if the paid days is greater than the current day that we're on, we can just go to the next step. So that's just going to be I plus 1, and we just carry forward the paid days. Great, so let's go ahead and run that. Looks good. And success. So that's the top-down approach, but I'll show you how we can translate this into a bottom-up way of doing it, which is much more performant. And so to do that, all that we want to do is typically you define a very explicit array here rather than implicitly creating your DP array. And so let's go ahead and define that. And initially this is going to be 0. And so what we're going to do, and I'll explain this in a second, but we want this to be as long as the last day in our days here plus 1. So basically for this example, we're creating a DP array of length 21. And that allows us to have basically a cell for day 1, 2, 3, 4, 5, 6, all the way up to 20. And so what this is going to represent is, okay, what's the minimum cost in order to pay up to this day? And this is a very common pattern for our DP functions is, okay, if I'm solving this, I want to first look at what's the minimum cost for 1 day, 2 day, all the way up to the cost for up to day 20 here. Okay, and so essentially we're going to store the final answer in the last day. So that's going to be, okay, day 20 is going to have like the minimum cost to reach all the way up to this point here. Okay, and so another thing that we're going to utilize is just, okay, travel days, and this will just be a quick lookup for the days that we're traveling on, so we can quickly see, okay, do we even want to travel on this particular day? Okay, and so what we're going to do is we're going to just iterate between 1 and the final day of the year that we want to travel. And so that's going to be non-inclusive, so we just add +1 here. And so there's going to be 2 cases. One is, okay, what if we don't even want to travel on this day? And so that's just going to be, okay, if the current day, so if I is not in our travel days, let's just carry forward the previous day. So then the cost for DP at I is just going to be the previous day's cost. So let's just kind of ignore it and carry forward the minimum cost. Otherwise, we're going to have to make some decision, and well, we have 3 of them. And so we're going to set then the cost for this day to be the minimum of these 3 different paths that we've talked about before. And so that's going to be either a 1-day pass, a 7-day, or a 30-day. And so for 1-day pass, let's just look at, okay, what was the cost of 1 day ago plus the cost of a 1-day pass. Okay, and so we're going to basically repeat this 3 different times, but for these 3 different cases. Okay, so this is for a 30-day pass and a 7-day pass. Now we have some edge cases here because what if we're on day 1? We don't want to do 1 minus 6 because that will give us out of bounds. So we can just do the minimum, or sorry, the maximum of this and 0, just so we don't get an error here. So let's do the same thing at this point, is just the maximum. Okay, so I think this looks good. Let's just go ahead and try running this. Oh, there is an error. There we go. Oh, so we got a problem here, so let's just think for a second. So we want to iterate through all these possible ranges. These are the days that we want to travel on. This propagates forward that answer. I'm not sure if we want 1, maybe I'm just being too careful. Maximum cost at 2, cost at 1, cost at 0. So all looks good. I'll just quickly look at, I don't want to spend too much time debugging this. So let's just look at my previous way of doing it and just compare. So that's my recursive one, and then this is that. So let's just quickly see what I did wrong here. Awesome. So let's just compare it. So this is the travel days, 0 for the last day plus 1, looks good. Day in the range of 1 all the way to the last day plus 1, looks good. If it's not in the travel day, we carry forward our answer that we're on. And let's go through the minimum of these 3. Oh, okay. So I'm doing -6 and 29, but we don't have to do that here. That makes sense. I think I was just worried about the bounds. So 7, and let's make this 30. All right, and so let's go ahead and try running that. We can also add that. And success. So sorry about that quick slip up, but I hope you enjoyed debugging it with me. For time and space complexity, it's just going to be O of basically the last day, so O of 20 for this algorithm. And then for space complexity, it'll be the same thing because we will be declaring basically an array of size O of the largest day here. Okay, so I hope that helped a little bit, and good luck with the rest of your algorithms. Thanks for watching.